Hi, just we have seen the derivation for energy of particle in rigid box or infinite potential well. So at the end we get the equation E is equal to n square h square upon 8 ml square, where n is a number which is integer but not 0, h is Planck constant, then m is the mass of particle, and L is the width of a rigid box or potential well. So depend on this formula, we can solve different numericals. So now we'll see numericals on a rigid box. The first numerical is lowest energy of an electron trapped in potential well is 38 electron volt. Calculate the width of the potential well in Armstrong unit. I am repeating this numerical again. Lowest energy of an electron trapped in potential well is 38 electron volt. Calculate the width of potential well. So here lowest energy is given, which is 38 electron volt. Lowest energy, so we can write lowest energy is E1, cause n is not 0, so lowest energy should be for starting from n is equal to 1. So E1 is given. So first, for solution, in given there is E1 which is 38 electron volt. So first convert these electron volts into joule. We know 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So E1 becomes 38 into 1.6 into 10 raised to minus 19 joules. Next, we know the formula for that. So energy of an electron trapped in potential well, which is general formula E suffix n is equal to n square h square upon 8 ml square. I've been repeating again, where n is the order or the number which is integer number. So it gives different energy levels. Okay, h is Planck constant, m is mass, L is width of that rigid box or potential well, and E, here E suffix n is the gives energy eigenvalues of different level n's. So n starting from 1 to different integers. Now, as we have given lowest energy, that time n is 1. Both side we have to put n is equal to 1. So lowest energy of electron is given by E1 is equal to, by putting n is equal to 1, so it is n square h square, instead of n we have to put 1, so 1 square h square upon 8 ml square, where L is the width of well. So when you have to find value of width of well, convert these equation in terms of L square first. So L square is h square upon 8 ml square. Just what we're doing, take this even this side and L square this side, but we want width. So as L square is h square upon 8 m 8 m even, so to get value of L, take its square root. So L is h upon root 8 m even. Why h is not in square root? Because this is h square. So square root of h square is only h. Now we can put the values here in this equation. So value of h is 6.63 into 6.634 into 10 raised to minus 34, which is Planck constant. Then 8 is as it is. Then value of m is mass of electron, which is 9.1 into 10 raised to minus 31. Then E1, which is given 38 electron volt. So we put 38 into 1.6 into 10 raised to minus 19. If you solve this, then you will get value of L, which is L is equal to 9.947 into 10 raised to minus 11 meter. Now see, this power is minus 11. For simplicity, we can convert these power in 10 raised to minus 10. So this 10 raised to minus 10 meter is nothing but Armstrong. So uh, shift the position of a decimal point. So it will be shift this side. So it becomes 0.9947. It will be 0.9947 into 10 raised to minus 10 meter and 0.99. So we can write it as 1, and 10 raised to minus 10 is Armstrong. So your answer will be nearly equal to or approximately 1 Armstrong. So now we'll see a next numerical. Calculate the first eigenvalue of electron in Armstrong trapped in rigid box of length 1 Armstrong. I'm repeating it. Calculate the first energy eigenvalue of electron in electron volt trapped in rigid box of length 1 Armstrong. So first eigenvalue means E1 we have to calculate. So what are the given? Given is width of potential well, which is 1 Armstrong. The L is 1 Armstrong. So convert into meters. So it will be 10 raised to minus 10 meters. And first eigenvalue, so N is equal to 1. So energy of an electron trapped in potential well or rigid box is E suffix n is equal to n square h square upon 8 ml square. This is standard equation. Now when we have to find its first energy eigenvalue, we can take n is equal to 1. So that time equation becomes E1 by taking n is equal to 1. Here also put n is equal to 1. So 1 square h square upon 8 ml square. Now we'll put the values from given. Here value of n is 1, then value of h, which is 6.634 into 10 raised to minus 34, which is Planck constant. Then this 8 as it is. Then mass of electron, which is 9.1 into 10 raised to minus 31 is mass of electron. Then value of L is 10 raised to minus 10, which is 1 Armstrong. So here is L square, so 10 raised to minus 10 square. If you simplify this by using scientific calculator only, please do not use mobile. So calculate it. If you calculate it, that time you will again get the answer. That answer is 0.603 into 10 raised to minus 17 joule. I'm repeating it again. 0.603 into 10 raised to minus 17 joule. Now we want answer in electron volt, so convert this joule into electron volt. So this time we should divide this value in joule by 1.6 into 10 raised to minus 19. When you divide this value of energy by 1.6 into 10 raised to minus 19, that time we'll get the value of first eigenvalue of electron which is trapped in rigid box of width 1 angstrom will be 37.60 angstrom. Next, a neutron is trapped in infinite potential well of width 10 raised to minus 14 meter. Calculate its first energy eigenvalue. If you observe numerical, these numerical similar like previous one, but difference is here is neutron, and in last equation or last numerical there was electron. So change a difference between electron and neutron in the mass, that value we should carefully substitute here. So given mass of neutron is 1.675 into 10 raised to minus 27 kilogram. Then width of well is given, which is 10 raised to minus 14 meter. Then we have to find first energy eigenvalue in the potential well. So we know the formula, E1 is equal to n square h square upon 8 ml square. Here for it is asked for first energy eigenvalue, so n is equal to 1. Now we'll put the values. So we'll get by putting value, n is equal to 1, then value of Planck constant 6.634 into 10 raised to minus 34, then 8 ml square, 8 value as it is, then mass of neutron, this value we should put carefully, 1.675 into 10 raised to minus 27, because frequently we are not using the particle like a neutron, so by mistake you can put value of mass of electron here, be carefully. Then L is 10 raised to minus 14. So if we solve it, that time just see here carefully, here is h square, so we have to take square of this value, then here also L square is there, so square of that value also. So by using scientific calculator, if you calculate it, then you will get the answer, E1 is equal to 3.276 into 10 raised to minus 13 joule. Most of cases we are going to find energy in terms of electron volt, so convert this energy in joule, which is 3.76 into 10 raised to minus 13 into electron volt by dividing this term by 1.6 into 10 raised to minus 19. So you will get the answer, E1 is equal to 2.045 into 10 raised to minus 6 plus 6 electron volt. I am repeating again, E1 is 2.047 into 10 raised to 6 electron volt. We know 10 raised to 6 is another prefix which is mega, so instead of 10 raised to 6 we use mega, and answer will become 2.045 mega electron volt or million electron volt. Okay, thank you.